Hi guys, welcome to my YouTube channel. My name is Anushar. I am studying in Sri Venkateshwara College of Engineering. Today we are going to discuss about the subject discrete mathematical structures. In that we are going to discuss about functional compositions. Function compositions. An overview of function composition and inverse function. Introduction. This presentation explores the concept of function composition and inverse functions, highlighting definitions and the properties of and applications in various fields. In this topic, we are going to discuss about the function composition and inverse functions. In that, mainly highlighting and definitions and properties and applications are discussed here. Function composition. Definition and notation. Function composition refers to the process of combining two functions to produce a new function. If f of x and g of x are two functions, the composition of these functions is denoted as f composition of g of x, that is equal to f of g of x. This means that you first apply g to x and then apply f to the result of g. This operation is not commutative, meaning that f composition of g of x does not necessarily equal to g composition f of x. Understanding this concept is crucial in mathematics as it allows for the simplification and evaluation of complex functions relationships. Properties and composition. The properties of function composition includes associativity, which states that the f composition of g composition of h of x, that is equal to f composition of g of composition of h of x. However, it is important to note that composition is not commutative, as we seen in the last slide. As previously mentioned, another property is the identity function, where for any function f and the composition with the identity function I results in the original function, such that f composition of I of x, that is equal to f of x, and I composition of f of x, that is equal to f of x. These properties facilitate and manipulate and understanding of composite functions in various mathematical applications. These are the properties we can see in the function composition. Applications in mathematical analysis. Function composition is extensively used in mathematical analysis to simplify and evaluate functions. Complex expressions can often be expressed as compositions of similar functions, make it easier to analyze their behaviors. For example, in calculus, one might compose functions to explore limits, derivatives, and integrals. Moreover, in linear algebra, transformations can be represented via functions compositions, enabling a clearer understanding of the relationship between different mathematical constructions. Second one is inverse function. Inverse functions. Definition and finding inverse. An inverse function essentially reverses the effect of original function. If f of x takes an input x and produces an output y, the inverse function denotes as f inverse of y takes that the output y and returns the original input x. To find an inverse function, one typically swaps the x and y in the equation and solves for y. Not all functions have inverses. A function must be bijective, meaning it is both injective one-to-one and surjective onto to possesses an inverse. Properties of inverse function. Inverse function have several critical properties. For any function f and its inverse f inverse, the following holds f of f inverse y, that is equal to y. For every y in the range of f, and f inverse of f of x is equal to x for every x in the domain of f. This demonstrates the reversing nature of inverse functions. Additionally, if a function is represented as f of x, then the inverse is expressed as f inverse of x. Understanding these properties enables mathematicians to solve equations effectively and transition smoothly between a function and its inverse. These are the properties of the inverse function. Applications in real world problems. Inverse functions are not just theoretical, they have practical applications in various fields such as physics, engineering, and economics. For example, physics. Inverses are used to determine time from speed and distance. In economics, inverse demand functions help understanding consumer behavior and pricing strategies. Moreover, in computing, algorithms often rely on the concept of inverses to decrypt information. By applying inverse functions, professionals can derive insights and make informed decisions based on the data. These are the real-time applications. Then we come to the conclusion. Understanding functions, compositions, and inverse functions is crucial for navigating complex mathematical landscapes and real-world applications. These concepts provide foundational knowledge essential for various analytics and quantitative fields. By mastering these principles, one can enhance problem-solving skills and apply mathematical reasons effectively in diverse scenarios. This is the conclusion, and thank you.